Hi, this is checkpoint 1.16. They want us to find the area inside of the circle. R is equal to 4 cosine theta, and outside of the circle R is equal to 2. Let's try to draw these circles here. R is equal to 2. I think that one's pretty straightforward. Radius of 2 from the center. And then the next one is the cosine, and I believe the cosine is going to be a circle shifted to the right, and it has a radius half of 4, so that's has a radius 2, and 1, 2, so the radius will come from the origin, and I think it'll look something like this, but we can try a couple of points, like if R is equal to, or theta is equal to 0, then 4 cosine of 0 is 1, so that's going to give us an R of 4, and at pi over 2 it'll be 0, so I think it'll come this way. So these are the two circles. R is equal to 4 cosine theta. Okay. I think we need the intersection because we're going to need a couple of angles. And one thing that we could try to take advantage of is that it looks like there's going to be symmetry here. And the symmetry will just be from, let's say, the positive x-axis going upward, and just multiply it by 2 instead of from the negative to positive. Anyways, let's continue trying to figure out what this angle is. We can find out that angle by setting these two equal to each other. We have 2 is equal to 4 cosine theta, and cosine theta is equal to 1/2, and that's equal to 1/2. I just but it's going to equal to 1/2 in a bunch of different angles, but let's just worry about what happens in the first quadrant, and that's going to happen at pi over 3. So we got pi over 3. This, if we care, is going to be negative pi over 3, but let's just say we're going to double this. All right, the area that's inside of this circle, it's inside of this circle and outside of the other circle. So let's cross this out. So I think the area that we're looking for is this little bit here. Okay. All right. Now we're finding the area. To find the area, if you remember the formula for the area is going to be 1/2 the integral from some a to b of f of theta squared d theta. But now we're looking at the area between two things. So imagine getting the area of the big one and subtracting the area of the smaller one. What does that entail? Well, they're both going to have a 1/2, and so area between two curves that's a pretty big subscript there. The 1/2 will factor out, and then we have common angles, and we have the bigger function minus the smaller function d theta. Okay, that is our setup. Which one's the bigger function, which one's the smaller function? The bigger function is going to be the farther away from the origin, so let's call this f1 here, and this is going to be f2. Okay, all right, let's go ahead and do this integral. We're going to double this. So the area that we're looking for is 1/2, or it's going to be double times 1/2. So let's make a note that this is doubling the area. We're only going to find the area here, and then we're going to multiply it by 2. Okay, so the double times the 1/2 will cancel itself out. And instead of going from minus pi over 3 to positive pi over 3, we're just going to go from 0 to pi over 3 because we're going to double it. And the big function first. And the big function is for cosine theta, and we'll square that. And the smaller function is 2. We'll square that, and then d theta. Okay. All right. So the 2's go away. We're integrating from 0 to pi over 3. This is going to be 16. We have cosine squared theta. We're going to do the half angle formula again, minus 4. And I think it might be better if we split this up to 2 different integrals. I'm going to switch pens and take the 16 out. And this integral, I think if you remember, was 1/2 theta, and the cosine I think is a plus 1/4 sine 2 theta. And we're going to integrate this from 0 to pi over 3, and the sine of 0 is 0, so that's going to go away, which is going to be good. We're going to be just focused on pi over 3. Minus 4, and then the antiderivative of 4 is just 4 theta. And we're going to go from 0 to pi over 3 as well. Okay, we have, let's just call this 8 times pi over 3, and 1/4 and 16 is 4. Sine pi over 6, nope, sine 2 pi over 3, and sine 2 pi over 3, 2 pi over 3 sine is still positive, and that's root 3 over 2. And then again, 0, 0, so we don't need to worry about this. And the same thing with this, we don't need to worry about that either. But we do have a minus 4 times pi over 3. Okay. We have an 8 pi over 3 minus 4 pi over 3, so that's going to be 4 pi over 3, and this cancels, simplifies a little bit to 2 square root of 3. And I think that's it. This, I think I punched this into the calculator, and this is approximately equal to 7.65289. Okay, that is our area inside of the big circle and outside of the, well, the same size circle, but inside of the circle for cosine theta, and outside of the circle r is equal to 2. Okay, I hope that helps.